In this video, we're going to talk about how to factor polynomials. This will be one of our three methods we talk about. We call this one grouping. Call it grouping because the very first step in it is just grouping. I'm going to take the first two terms and the last two terms. I'm going to write those terms in parentheses. Now it's very, very important to be mindful of the negatives again here. I have minus 25x minus 50. So if I subtract this parentheses, I have to make sure that if I were to distribute this negative, I would get the same thing as above. What that's going to leave me with is 25x plus 50. Right? If you're not quite sure, just kind of go backwards. Minus 25x, good. Minus 50, there we are. I have two groups now. Now with each group I want to factor out the greatest common factor. What that means is I take a look at the two terms, I figure out, okay, what factors do they have, and what is the greatest one I could take out of them. So for example, I have x cubed and I have 2x squared. The coefficient of the x cubed is a 1. And so they both share just a 1 as a coefficient, which doesn't really do anything. But for x cubed and x squared, they share an x squared. So I'm going to factor out x squared there, and now I have to figure out what is still remaining in the parentheses. Let's see, x squared times x, if I distribute it here I get x cubed, so it'll be x plus 2. Okay. Now for the second one, I'm subtracting. I have to look for the greatest common factor of 25x and 50. Look at that, they don't share any x's, so I can't factor an x out. For 25 and 50, I can factor out a 25. So if I take 25 out of 25x, I'm left with just x. And if I take 25 out of 50, I'm left with 2. Now if you've done things correctly, and this is a polynomial you can factor by grouping, you should end up with two binomials, that is terms with two different terms, and they should be exactly the same. So what I'm going to do is, just as I factored a common monomial out of here, I pulled a single term out of each group here, I'm going to factor out this common binomial. So I take the x plus 2, I'm going to factor that out, and now what's left in this expression is going to be everything except for the x plus 2's. So I get the x squared, and then I took the x plus 2 out, but I still have the minus 25. Okay. So at this point I have factored this degree 3 polynomial, this cubic, into a linear term and a quadratic term. Now the last thing to do is take a look at the different factors you have and see if you can factor any of them. In this case I can factor x squared minus 25. That breaks into x plus 5 and x minus 5. I still have this x plus 2. So there's my complete factorization. If you're not quite sure about that last step, go back and review factoring quadratic expressions. What I've done here is I started with my cubic polynomial. I grouped them into two different, the first two and the last two. I factored out common monomials. I had the same binomial, so I factored out the common binomial. And then when I got to this end spot, I just factored the quadratic. Example number 2, it starts off kind of messed up here. It's negative 9x plus 7x squared minus 63 plus x cubed. Now, in the first example, it was already given to us in descending order. The biggest exponents are first, followed by the next biggest, followed down to the constant term. In this case, the first step is going to be rearranging things. So first I have x cubed. Next I'll go for my x squared terms. So plus 7x squared. Then I have minus 9x. And then my minus 63. Right. That was a step that we did not have to do in the first problem because it's already in order for us. Now it's going to be the same steps. I'm going to have a group, then factor out the greatest common factor, and then hopefully factor out the common binomial, then see if there's any factoring I have to do to finish off the quadratic. So grouping, get x cubed plus 7x squared minus 9x plus 7, or I'm sorry, plus 63. Right? Again, be very mindful of the negatives. Factor out the greatest common factor from each group now. So x cubed and 7x squared share x squared. Then I look at 9x and 63. They do not share any x's, but they do share a 9. So I'll factor out a 9. That will leave me with x. And then since 9 times 7 is 63, I have 7 remaining. Okay. Take a look at where we are. The binomials we have now are both x plus 7, so we can factor out that. So you take out x plus 7. So you kind of pretend that those aren't there anymore, and you write what's remaining. X squared minus 9. This is our first factorization of this cubic. We're down to a linear term and a quadratic term. The last thing to do is check, can we actually factor this quadratic? And yeah, we can. That splits down to x plus 3 and x minus 3. So to summarize, if we're going to factor by grouping, what we have to do is we start with our cubic term, and we put it in descending order. So biggest exponent, next biggest, and then the number. We group things together and see if we can factor anything out. If we can factor something out, and further the binomials end up being the same, we can continue to go through this and factor this in by grouping. If anywhere in these first few steps doesn't work out, it doesn't necessarily mean you can't factor. It just means that this method's not going to work for you.